All right, so today is Monday, October 11th. As advertised this week, when we talk about object-oriented programming, kind of a mouthful to say, but overall, just another way to kind of structure your code and kind of the way that many projects are kind of designed in. So we'll talk about object-oriented programming, kind of talk about why we want to use it, what it actually means, and then we'll kind of see some coding examples to get you comfortable with it. All right, so as mentioned, in the past week, we were doing algorithmic challenges. Now we're going to get to more designing code solutions as well as still having algo solutions. But object-oriented programming deals with designing kind of proper structures within your code. So let's kind of get to that. So the title of the presentation is Making Your Code Classy. All right, so I've mentioned this before, and I'll probably mention it again in future. There's two main goals of a software developer. One is to solve a problem. So as you mentioned, if you have an idea to solve whatever challenge you're dealing with, go for it. Like there's no necessarily wrong way to do it, but there can be improvements that can be made. So the second task of a software developer is to actually solve a problem well. So that's when we talk about structurally, functionally, algorithmically. Sorry. There's many ways we can improve our code solutions. So structurally, we talk about code organization, system architecture, the idea of future proofing. So again, if you develop an application right now, great, it might work and service your needs, but make sure that, what if your customers go from 1,000 to 1,000,000 customers? Is your application going to be able to handle that? Many things you can think about for future proofing. Obviously, there's no way to predict the future reliably. Like what if the needs in the future change that you didn't expect? That's totally fine. Just plan as best as you can. And we also talk about reliability. So is your code safe? Does it crash? And does your application kind of go down often? Do you have proper checks in place? And then readability. Things like following style conventions, commenting your code, many ways to make your code more readable. So we're going to be talking about code organization. That's where OOP kind of falls into, kind of how you structure your code to kind of make sense and be easy to use and reuse code. All right, so there's many programming paradigms out there. We're going to be focusing on object-oriented programming, but just to let you know, that's not the only paradigm that exists out there. There's functional programming, procedural programming, structured programming, logical programming. I'll be honest, I couldn't tell you all the details of these because one, I have not really used most of them, and two, OOP kind of just like the prevalent one that you'll run into. So that's why we're focusing on it today. All right, just know that others exist. You can Google them. I think there's a Wikipedia page that kind of talks about all of these. So definitely have at it if you're curious about other paradigms. But OOP is what we're going to focus on today. So this slide is very theoretical. Don't worry, you're not going to have to memorize this. I'm just presenting it because this can be interview questions where they ask you, all right, can you describe polymorphism to me? These are the four main features of OOP. So I just want to cover them. We'll talk about inheritance in detail, I think, on Wednesday. But the idea here is just sharing similar features and attributes with your structures that you're using. And this just goes back to the main principle of reusing code. Again, we talked about the DRY principle, I think, in passing. DRY stands for don't repeat yourself. Inheritance kind of allows you to naturally reuse key components between shared objects. There's an idea of polymorphism, and I will say it is kind of hard to see polymorphism at play in Python specifically, just the way Python kind of operates. But this idea that objects can take different forms depending on what your situation is. For example, let's say we have a dog object in our code. The dog object has some special features making it a dog, but also it has features that are just natural to pretty much any animal. So polymorphism is the idea that if I want to do something that's animal related, I should be able to do that, and my structure should be able to kind of take the form of an animal and not have the extra components of a dog when needed. But also, if I need to do something else particular to a dog, polymorphism again allows me to do what I need to based on my use case. So again, your object can take a different form depending on what you're trying to do with it. The idea of abstraction is basically you're just hiding away complexity from your end user. So basically, if I have, let's say, a method on my dog class that says speak, I don't need to really know how that function works. It's basically abstracted away, and I just know what the input is and what the output is. And then there's the idea of data encapsulation. This is basically creating like a black box where, again, things are not exposed that don't need to be. Again, this is a little hard to kind of see in Python because they don't have data protection. But if you think about it, if I create an object that has some sensitive data, that data should not be exposed externally. So let's say I have like a human class and I have a social security number in there. Well, I probably don't want to expose a social security number to anyone using my human class because that's private information. But I might want to have a method that says has valid social security number, or get last 4 digits of social security number and return them, right? So the idea of encapsulation is, again, only exposing data externally as needed, as in you don't have to expose everything that your class has inside of it. All right, so again, these are 4 buzzwords that you will see repeatedly when you're kind of learning about OOP, but just kind of know about them, research some more. Definitely, like if you're having an interview where they're going to talk about OOP, maybe brush up on these 4 concepts. They may ask a question about them. That's the only reason we're presenting them here. Otherwise, you're not going to have to worry too much about this in our curriculum. Any questions about these 4 main pillars? Again, we'll be talking about inheritance more in detail. These other 3, you'll kind of see them at play, but we're not going to go too much into them. Okay, so classes. So classes are the main structures that we use with OOP. Classes are basically user-defined types. So we've been working with some classes already, whether you knew it or not. Like a list is a class. It has methods. It has internal members. It has various behaviors that we can behaviors we could call upon. So we can create user-defined data types. So instead of just using whatever's built into Python, like dictionaries and lists, we can create our own data types to kind of better create structures for our particular use cases. Classes are used to tightly bind data and data manipulation methods together. And this is the idea of encapsulation. It's all encompassing, it's a black box. Everything that we need should be packaged into this class. So for example, if you have a dog class, we might have a method, or we might have a data member that says, our dog's name, for example. If we need to change our dog's name, we should have a method that will change it for us. We shouldn't be kind of manipulating the data externally. And this is very conceptual. You could definitely get away with it, but the proper design for OOP is to have methods that manipulate your data already created inside of your class. You shouldn't have to, update your data manually outside of your class. The reason why object-oriented programming is very popular is because it's very useful for mapping real-world objects. So the idea of OOP is basically creating objects, basically something that reflects, like if I have a dog in the real world, a dog has properties, like it might have a name, might have a fur color, a breed. We're creating something in our code that has the same kind of idea, where we have something, an object that has attributes in it, and then a dog has things I could do. We could maybe roll over, it could play fetch. These would be methods inside of our class. So we would have a fetch method or a rollover method. The main way to kind of understand classes is that when you create a class, you're creating a blueprint. So you're not really creating anything. It's a concept. So if you think about a dog, you have an idea of what a dog would be, but then when you actually create an instance in your code, that's like a physical manifestation of a dog. So again, there's an idea of a dog, but then let's say, you have a pet that's, right next to you right now. That is an instance of that idea, right? So, if you, do we have any pet owners out there or any dog owners?
Yeah, I got a puppy right here.
Represent.
Who has a puppy?
Zach.
Zach, what's your puppy's name?
Baxter.
Baxter. So yeah, Baxter is an instance of a dog. Versus a dog, again, we think about a dog, cute puppy. A dog generally has 4 legs, has some fur, generally barks. So again, all dogs kind of have some similar characteristics. We have an idea of what a dog would be, but when we actually see an instance of a dog, we actually create a real world object from our blueprint. right? So a class is a concept or a blueprint. Objects are instances created from those blueprints. Right, so we talked about there's two main items that you'll find in a class. One are attributes, and these are just data members, also known as variables inside your class. And we have methods. So we use the word method and functions kind of interchangeably. In Python, I believe functions are just what you create standalone functions that take in inputs, outputs. When you have a function inside of a class, those are known as methods. So these methods are what actually manipulate and act upon your data. You can have getter methods, which basically give you back the data members, which aren't as important if you're not modifying it. But you'll have setter methods, which actually update your data. Okay, so again, attributes are your data members. Methods are your functions that interact upon your data members. All right, let's actually see an example here. So I'm going to go to my coding window here, and let's kind of create an example. So I'm going to create dog.py, and let's add some code here. So Zach said he has a puppy, so I'm going to create some representation of his puppy inside of our code. So first, I'm just going to create a variable called name, and we'll say Baxter as name, and then what kind of breed or what breed is your puppy? Do you know, Zach?
Yeah, he's a Labradoodle.
I don't even know how to spell Labradoodle. Say lab. Keep it short. And then what color is your dog?
Black and white.
We'll go black and white. All right. Cool. All right. So we have some variables here. And then if we wanted to like print something out about Zach's puppy, we could say, let's have an owner maybe. All right. So we'll say, let's create an F string to do owner. Okay, so if we do this, let's print that out and see what happens. We want to do Python dog. All right, so we get a simple statement. Zach's dog is named Baxter and is a black and white lab. All right, nothing too fancy there. But here we just have variables that aren't really connected, as in they're just standalone variables. They're not really packaged together. Let's say we want to create another dog instance. Does anyone else have a dog that they want to share, or just a name at least? Duncan, I think you said you have a dog. What's your dog's name?
Bailey.
Bailey?
Mm-hmm.
Bailey, I think I heard. This was Duncan's dog. What kind of dog is it?
Also, she's also a lab.
All right, and what color?
Black.
Black. All right, so we have another dog here, and then we could do the same thing. All right, but notice maybe add some numbers here to distinguish these. And all right, so we are able to kind of accurately reflect these two dog instances. However, we're kind of getting some repeated code here. Notice that I need to kind of create these variables and then recreate them here. And also this print method is effectively the same, it just has different values in it. If we went through the entire class, and let's say, a dozen of you guys are dog owners, then we'll kind of have to do some copy and pasting and kind of, doing the same thing over and over. And as we talked about, this generally isn't the best approach as a software developer. You want to avoid reusing code or having duplicate redundant code as best you can. Also, another issue with this, again, these variables exist, but they're not really paired together. As in, let's say I want to call a function. So let's do a def, let's create a function, print dog details. And this will be our print statement that we wanted. Move that here. This will take in an owner, a name, color, and breed. All right, so now we're kind of, again, functions, as we talked about, kind of help us reuse code. So instead of having the same print statement multiple times, we have a function that will do that for me. So we're kind of reducing our code, which is great. So here I could just call print dog details and pass in owner one, name one, read one, right, you guys kind of get the idea here. So we reuse some code, but our variables, again, they're just kind of detached, right? When you think about a dog kind of has all this packaged together, as in the name is a property of a dog, the breed is a property of the dog. It's not like some standalone data that exists outside of the dog existing. Does that make sense? So this will work for our needs, but it's maybe not the best approach. All right, let's do that. Should work like before. All right, so we got Zach's dog is named Baxter and it's a black and white lab. Duncan's dog is named Bailey and it's a black lab. All right, so this works, but again, we still have an issue here about having this detached data. Again, none of this data is necessarily associated with one another, aside from the fact that we kind of bundle it together as we call this method. All right, and this is where classes come into play. So we're going to create our first class here. Let's go down and get some space. So if I want to create a class, we do that with the class keyword. So if I do type in class, notice that VS Code identifies it as a keyword, so it highlights it as such. But you use the class keyword and then give your class a name. In Python, we use camel case, starting with the uppercase. If I want to create a dog class, I'll name it dog with a capital D, and then let's put a pass here. So now this is the simplest class you can have. Again, my class is not doing anything. It's not storing anything, but this is a class. So dog is a class that now I could use. And this is a blueprint. So right now this dog class is nothing too exciting, but I can still create an instance of it. So let's create Baxter, for example. So now I've actually created an actual object. So Baxter is an object, dog is a blueprint. So I'll make sure that these ideas are kind of being understood. So I have a concept of dog here, and when I actually create an actual instance of a dog, I have an object, Baxter, which again represents a real dog. Any questions about the terminology I'm kind of laying down there? Again, class, concept, idea. Instance, object is an actual creation from that idea. So imagine like a factory, you have a factory that makes dogs, I guess. You have a blueprint on how to make dogs. But when you actually want to make a dog and you spit one out, when the factory spits one out, that's when you actually have an actual, dog you can interact with. Probably not the best example. We talk about products instead of dogs because they're not made in factories, but anyway. All right, so this is our first class. Again, very simple, doesn't really do much, but we still create an instance of it. Let's actually give our dog class a little more pep, right? So I'm gonna kind of copy some code from our curriculum page just to go with that example, but I'm gonna copy our dog class. So voila, we'll make this a little more involved here. Let's get rid of our terminal. So I created a dog class that has some attributes in it. Again, we talked about attributes being data members. So we have a species, we have a sound that a dog might make, maybe a number of legs it might have. We also have a name, breed. Let's have color in here. And we'll talk about what all of these special things mean. Don't worry. Self.color. Color. Let's still use Baxter here. So I'm going to get rid of Fido. Let's use Baxter. It's a black lab. And we'll say black and white. All right, Baxter will speak. Say wolf. All right, so we created a class here. We're passing in some parameters. So now we have a name, breed, and the color of the dog. Let's talk about all the details here because we kind of introduced a lot here. So we still have our class keyword. We have some data members up here. These are what's known as class attributes. Class attributes are something that's going to be shared pretty much by all instances that you create. So what I mean by that is every dog that exists from this blueprint is always going to be the same species. So that's why I put this as a class attribute, as in every member of this class is going to share all of these items. Now, there might be exceptions, and we'll get into that, but for the most part, these are general properties that apply to every dog that's going to exist. On the other side, we have something called instance attributes. These are values that are specific to each individual instance of a dog that gets created. So example, we have Duncan's dog, which is named Bailey, and we have Zach's dog, which is named Baxter. the name is not shared between both those dogs. They have unique names, individual names. That's why these are instance attributes, meaning each instance of this dog class is going to have a unique value versus both Duncan's dog and Zach's dog and pretty much every dog out there is the same species. Now, not all dogs might say the same thing, but for the most part, we're generalizing that all dogs are going to say woof, and then all dogs have 4 legs. Again, some dogs do not, that's fine, but this is the general case. All right, so again, instance attributes are unique to each instance that exists versus class level attributes are shared between every instance. So every instance has the same species, but not every instance has the same name. All right, so that's the first thing I want to make sure we understand. This is something that we're going to kind of hammer in, but kind of just understand sometimes based on your use case, you want to create instance attributes or you want to create class attributes. And the decision that you are making is basically, does every instance of this class have the same value, or does every instance have different values? So again, I think you guys will all agree, dogs have different breeds, have different colors, but they all generally say the same thing and have the same species. Questions about instance attributes versus class attributes?
I have a question.
Yep.
I was gonna ask if is there a way to assign like anything like default values or anything like that if you basically don't predefine it, like so the legs, instead of having it as an instance where it is universal, you just default it to 4 and then you would have to specifically update it to 3. Is there any way to do that, or is that not? You have to just, when you build the instance, you have to update each attribute.
No, that is possible. So if I wanted to remove my class level attribute, and then I can make this instance attribute. So if I did self.legs, and then maybe having legs equal 4. So I think this is maybe what Michael was suggesting. We're going to have a default value here.
So you have the default value up there. So you don't have to, every time you create an instance, or you won't have to put legs in there. It'll assume 4 unless you put something. Got it.
Correct.
Thank you.
Yes. So this will allow you to kind of control the number of legs for each dog, which isn't wrong. Like, again, we've talked about, I've definitely seen YouTube videos where like, some dog has like 3 legs that, they're still a happy dog, but they just kind of hop around for whatever reason they're missing a leg. So yeah, some dogs might not have exactly 4 legs. So you might want to have that as instance attributes. Again, as I mentioned, you guys are going to be designers. So any design decision you make, you're going to have to back up. So there's not necessarily 100% right or wrong decision here for like in the case of legs. I could definitely see a case for it being an instance attribute. But again, any design decision you make sure you can back it up. Don't just kind of say, I just did this just because, right? Sean, you have a question?
Yeah, so is, just for my understanding, I don't know if I'm getting ahead here, the selves that are on the instances, that's when we're declaring like an instance of this class, and that's why a self would be there every time.
Yeah, let's actually talk about that. So we've seen the self keyword in our unit tests, and we didn't really say what those are. So self is a keyword that is required for all instance methods. We haven't talked about instance methods in particular, but basically any method you create inside of a class, for the most part, is going to be an instance method. And if it is, it has to have a keyword. It's got to have something, it's got to have a parameter at the beginning to capture the instance. This does not have to be named self. I can name this donuts if I want to. I can name this something. This is just a variable, just like any other variable that you pass in and name for a function. But by tradition, we always call it self. Right? In fact, it's so much so the norm that VS Code knows that self is a kind of it's not a reserved keyword, but it's a typical keyword that it highlights it in blue, identifying it as something special. If I did this as something, it's not going to know, VS Code doesn't know that something is, again, something that's unique, I guess. Self, again, is the default name that we go with. So kind of just stick with that. Don't try to get creative. Like, I don't want to call it self. I'm going to call it something else. No, just play along and always name it self. So self will be the first parameter for any instance method that you have. Then you'll be able to use or access data members off of that instance. So what I mean by that is, let's do a print statement down here. Print Baxter.name. So what's going on here is I created a dog instance, and my variable is named Baxter because the dog is named Baxter. But anyway, so if I do Baxter.name, what that actually is doing is referencing the same thing that self.name here is referencing. All right, so this self actually refers to Baxter in this case. So all these items, name, breed, color, and legs, are being attached to this Baxter object. Now it's being done in this magical init method, which you guys might be kind of wondering about, like, why is it named such? We'll get to that. Basically, these data members are being attached to this object. And again, this goes back to the idea we were talking about earlier, like above. We had all these variables that weren't really tied together, or, really associated in any manner, aside from the fact that we're using them together. OOP kind of gives us this ability to kind of bundle things together. So within this class, name, breed, and color and legs are all part of Baxter, which makes sense because, like, if you think of a dog, name is kind of a property attached to that dog. It's not something that, again, is just a separate idea. Was there a question out there?
Yes, I was just kind of curious, is there a particular reason you couldn't just, like, say, go back to the legs equal 4 thing and then maybe change that class attribute for just that one instance of a dog? Or would that, like, break the entire class? So kind of
No, you're right. So yeah, we had a couple of design decisions that we made here. So initially I had legs as a class level attribute, meaning I envisioned basically every dog having 4 legs, but there might be exceptions to it. I think that's what Ty is getting to. So yeah, for now, I'm going to go back to the example, but again, this isn't wrong. I'm not saying having legs as an instant attribute is the wrong approach. Again, this is designing, so it can be subjective. But just to kind of highlight some additional things we're going to go over, I'm going to make this back class level attribute. All right, so again, the main thing here is this self keyword is referring to Baxter, because Baxter is the object I created. If I created something else, like let's say Bailey was our other dog, let's create another dog instance. So again, dog is kind of like a blueprint. I'm using it to produce dog instances. So if I do Bailey and then lab, and I believe black. So I'm creating another instance. So this Bailey and Baxter, they're 2 separate instances. Each of them are just going to have a name, breed, and color. However, they're both going to share the information I've highlighted here, because these are class level attributes. Both are going to have the same species. In fact, they're actually using the same data member. These data members are not being copied or duplicated. They're being created once and shared by all dog instances that get created in the future. So if we have 1 million dog instances, we still only have 1 entry for species, sound, and legs.
So that was my question. If you changed legs for one of the dogs, it would change it for everything?
Yeah, if I had a class level attribute and change this to 3, so that would actually change it for all dogs. We'll talk more about updating class level attributes in a moment, but good thoughts there. All right, so we have another instance here. So again, if I called the init method, this self will refer to any object that's calling it. So in Bailey's case, when this init method gets called, self is going to refer to Bailey. So imagine instead of self here, you might have Bailey. All right, so that's all the self keyword is doing. It's referring to the object that is calling the method. So if I call Bailey init, then Bailey.name, Bailey.breed, Bailey.color will be what I'm updating here. But again, self is just the generic keyword we use, because obviously we don't know what instance is calling us. Okay, so again, we can access these members freely. They are not private members, meaning we can print out, if I want to print out Bailey's breed, for example, I can do Bailey.breed. Again, so the way we access data members is via the dot and the name of that parameter. So if I do Bailey.breed, let's get rid of Steve for now. Clear. All right, notice we get Baxter is the name of our dog, and then lab is the breed of Bailey. We get rid of the code up here because I don't think we need it anymore. any questions about what we've done so far? Again, just kind of introducing classes, getting warmed up with them. We'll talk more about some other things we could do with them. Let's talk about this init method. I think that's something I kind of didn't mention yet. So this is a special method for classes. Again, this is just the way Python expects your classes to be structured. Again, it's looking for a class keyword. Python specifically is going to look for an init method. This init method has 2 underscores before it and 2 underscores after it. You must have this exact form and name for your class to kind of work as Python expects it to. All right, so that's underscore underscore init underscore underscore. This is what's known as a dunner method. Anything with underscores, again, in Python, they're known as dunner methods. I don't know where the name came from necessarily, but these are just special methods that all classes kind of have access to. Init is basically, as you might guess, initializing your class. So you get to specify what parameters your class requires. Again, self is required. So no matter what, if you don't want any parameter, you still need to have a self in there. But if you, again, want additional data that you want to pass in from the outside, your init method is the one that should be handling them for the most part. Not always, but anything that needs to be initialized, as in your dog needs to have a name, breed, and color. Well, we're gonna mandate that whoever creates a dog instance has to specify a name, breed, and color. That's going to be attached via data members. So the init method is actually creating variables on the spot. So this dot name is actually being created right here. It's not coming from somewhere else. It's not, magically, just getting created for us. We're creating a variable called name. We're attaching it to the object, and we're assigning it whatever we pass in. Just coincidentally, the variables I've passed in are the names of the data members I'm creating, but you don't have to. Like, I could call this dog name if I want to. I could call this dog breed. I could keep this color if I want to. In that case, my variables that I'm passing in would obviously have to be updated here, but my data members don't need to match, right? So I don't need to call this dog name. I can name that whatever I want. I'm just creating another variable, same way we were creating variables up here. All right, so there's a init method, again, def to create a function, declare a function, and then underscore underscore init, and make sure you remember your self keyword. I will probably wager a guess that most of you are going to forget the self keyword every now and then. Totally fine. Just get in the habit that every instance method needs that self as the first parameter. If you omit it, you will run into some issues, which we might explore later. What questions do you guys have about the init method?
So Ankur, the init method kind of makes all of those variables accessible in the class later on, right?
Yeah, so it's creating, so again, the init method is doing a couple things. It's creating variables and assigning values to them based on what you pass in. One thing I didn't mention that you guys might have a question on, notice down here, I'm simply calling dog, the class, and then in parentheses, passing in values. I am not actually calling the init method myself. This is something that Python's doing behind the scenes. So Python's saying, okay, you're creating a dog instance, you're passing some variables, I will call the init method for you. So Python's going to say, okay, let me grab those values, pass them in here, and then do all this stuff for us. So the init method should not be called directly by yourself. It'll be called by Python automatically.
So with that, then, if we wanted to improve upon our TDD tests a little bit better, we could set some of those values in an init function or an init instant attribute to access them later, right? Because our test, our TDD stuff, we aren't able to access variables in each one of the functions. So if we called them here as like test cases in an init function, after we declare the class, could we access them later on?
If you're talking specifically about the unit test framework, there are ways to kind of create variables and use them across test cases, if that's what you're asking.
Yeah, that was kind of my question here, because like this seems like it's a little bit more usable and user friendly than, because we haven't used the init function in our class for test cases yet.
Gotcha. I will let you know. So obviously it's a little outside the scope, so I'm going to table it, but there's a couple methods called setup and tear down. So if you read the documentation, setup and tear down lets you kind of create some items that you can use between test cases. There might be some other methods that you want to explore, but just read documentation if you want a little more detail on how to accomplish what Seth talked about. But yeah, so
Hey, Ankur.
Yep.
There's no private variables in, are these all public in
correct, yes,
Python?
in Python, everything is public. So if you are familiar with data protection or data access levels from different languages, that doesn't really exist in Python. So don't have to worry about that, but also don't have the capability for that really.
Okay, thanks.
There are some naming tricks you can use to kind of convey that something's private. You could use double underscore. Again, this is still going to be public, but effectively anyone reading your code should understand that this is going to be private. We're not going to get too much into that at this point. We're just kind of learning about classes. But okay, again, init method, for the most part, every class you create should have an init method. The only reason is if you don't have any parameters you don't want to pass in and you don't have any initial stuff you need to do, then you could kind of omit the init method and Python will create an automatic one for you. But for the most part, you probably will be creating init methods. Again, this is a method that automatically will be called by Python when you create an instance of your class. All right, so make sure we kind of understand why we need an init method. Again, anything in here is always going to, like this code's always going to execute. So if we need to do something else, like let's say we need to do, that's a good example. I'm not sure, like self dot, what if we had like a counter? I don't know if this is a great example, but let's say we had a counter of dogs. Maybe you want to update dog dot counter plus equals 1. I'm not sure if it's a great example, but we're keeping track of how many dogs we create with this counter variable. So the init method always going to get called. So we are going to always increment our counter. Notice that I've chosen to use the class name here to increment that value. That's because this is a class level attribute. So I would, generally speaking, use the class name, not the self keyword, to update my class level attribute. That's not to say that I can't do this. This line of code and this line of code will do the same thing because this counter variable has never been created before. So because I'm reading from it, it's going to know that I'm getting the class level attribute because there's no instance level attribute that matches counter. And we'll get into this when we talk about this legs attribute. So stay tuned if that kind of.
Wait, Ankur, which is preferred again?
If you want to explicitly update the class level attribute, I would do it this way. But if you know that there might be an instance level attribute, probably go this way.
Okay, thank you.
Yeah, I would say for the most part, you probably be doing this because if you specifically create an instance level attribute to override the class level attribute, then this will do it smartly. Again, we're kind of getting ahead of ourselves, so let me just stay on track. Anyway, init method can do any initial stuff that you have to do for your object. All right, so we created some data members. Let's actually create an instance method. So I'm going to create a speak method. So let me uncomment my code that I had before. So we have the speak method. And again, think about any object. An object has properties, but also has kind of verbs attached to there, things that it can do. Like if you have a ball can roll. The roll is not, a data member, but it's an action that the object can do. So in this case, I'm going to have a speak method for our dog class. Again, this is an instance method, so it must take in a parameter, and that parameter should be named self, because that's going to capture your object that's calling this method. So my speak method is simply going to print out to the console self.sound. So in this case, woof should be printed out. All right, so if I want to quickly use this, I can do something like, let's say Bailey is going to speak for us. So again, this is a function, so I call it with parentheses. Important thing to notice here, I am not passing a parameter in my speak method, right? There's nothing here, no parameters. However, my speak method takes in a parameter. So this is something slightly confusing. You're like, well, this looks like I pass it one parameter, but I'm actually not passing anything here. That's because, again, another magic of Python behind the scenes, because this is a class, Python knows to pass that object as a first parameter. You do not need to pass Bailey here. So just make it clear. Do not and should not pass Bailey as a parameter, right? Because this is not going to be attached to self. It's going to be an extra parameter and then this extra will contain whatever you pass in here. All right, so again, you do not and should not pass in the object yourself. Python will handle that for you. So if I save this and bring up my terminal, control tilde, let's see Bailey speak, Python dog. All right, notice we get woof. Baxter was name up here. So, all right, so we get a woof there. All right, so we have a method. That method is accessing data member here and is printing it out. Again, this self.sound is coming from this class level attribute. Now it might be confusing. You might be asking, why are you using self when this is actually a class level attribute? Well, I'm glad you asked that, or maybe we're thinking that. Let's go back to Baxter. Let's say Baxter wants to speak. All right, Baxter will also say woof because all dogs say woof, right? But let's say, hypothetically, let's say Zach trained Baxter to say something else. Well, this is a case where we don't want to use the default behavior for all dogs. So we can get around this. Now there's a couple ways to do this. Let's create a method. Let's say that updates sound. Okay, this is an instance method, and we're gonna update self.sound to be new sound. All right, so in this case, this instance method takes in one additional parameter. Again, always takes in self. We're gonna specify a new value that we're gonna update this to. All right, so if I do Baxter dot sets, what do I call it? Update sound. And Zach, what do you want your dog to be able to say? Or what have you trained your dog to say?
Bark.
Bark. All right. All right, so kind of a question for you. Looking at our code, I wish I had more space here. Let's look at our code up here. So I think I can fit it. All right, there we go. Notice that we have a class level attribute up here. Sound is something that's shared by all dog instances. However, I'm calling update sound, which is going to be updating self.sound to a new sound. The question I have for you is when we call Bailey speak, what is Bailey going to actually say? Is Bailey still going to say woof, or would Bailey say bark? Because we are updating self.sound to bark here. So that's a good question to have. Let's actually see what happens, and then we'll talk about it. So if I bring up my terminal again, if it will come up, there we go. The question is, will we get bark woof, or will we get bark bark, or we get woof woof? Let's see. So Python dog. Notice we get bark for the first output and then woof for the second one. So the first output is from Baxter speaking, the second one is from Bailey speaking. So what's going on here actually? Right here, we're actually creating a new data member. Same thing that happened kind of in the init method. We are creating a new variable called sound and attaching it to only that instance. Again, that self is referring, in this case, to Baxter. So Baxter is effectively getting a variable called sound. We're setting it equal to bark. All right, so we could do it this way, but as we talked about, usually you don't want to update data members outside of a class. But to be clear, both of these are valid and possible in Python. So I could do Baxter.sound equals bark, and this creates a new instance attribute just for Baxter. This does not affect Bailey at all. So Baxter now has a new variable called sound, and that value is called bark. Bailey, on the other hand, does have access to a variable called sound, but that variable is sitting at the class level. So Bailey, when we call self.sound on Bailey, what actually is happening is Python is saying, all right, we're looking for a sound variable on that instance, in this case, Bailey. Python's going to say, hey, there's no sound variable that exists for Bailey specifically. So at that point, Python's going to jump up to the class level and say, hey, is there some variable named sound or some data member? Sorry, I should be saying attribute. Is there some attribute called sound at the class level? In this case, yep, it does find an attribute at the class level. So it's going to use that. All right, so that's what's going on for Bailey. Bailey does not have an instance level attribute, but Bailey does have access to a class level attribute called sound. Baxter, on the other hand, Again, both of these are doing the same exact thing. I'm gonna leave it as update sound. Baxter, on the other hand, created a instance level attribute called sound. So when we call Baxter.speak, self.sound is going to refer to Baxter's sound attribute rather than the class level attribute for the dog class. All right, so again, I know we're saying a lot there, so I want to make sure we pause. What questions you guys have about what's going on here? So in one case for Baxter, we're creating an instance level attribute called sound that, again, that will override the class level attribute. The instance level attribute gets preference over the class level attribute. However, if we did modify our speak method and called dog.sound instead of self.sound, let me ask Kevin, what do you think this will impact in terms of our output down here? So I changed it from self.dog to dog.sound. Sorry, self.sound to dog.sound.
You know, always give the class output. Can you hear me? Hello?
I'm not sure I could hear you, Kevin. That's all right.
You're like really quiet.
That's right. I think I could channel Kevin's mindset. I think he was gonna say, when you change this to dog.sound, now both Baxter and Bailey will say woof. So let's give that a run.
Can you hear me now?
Yes. Okay. Yeah, we can hear you now. Kevin, do you have anything you want to share? Oh, can't hear you anymore. Not sure what happened. Okay, but yeah, so notice when we change it to dog.sound, we got woof and woof. That's because now we're explicitly saying we always want to use the class level attribute no matter what. So even though Baxter has a sound attribute that we created via this update sound method, it's not going to use it because this is specifying always use the class level attribute. But when you use self, and usually you want to use the instance attribute, instance keyword all the time, that's going to say first search the instance for this value, and if not, search the class level. All right, so again, kind of understanding class level attributes, instance level attributes is kind of one of the key takeaways from today. So make sure you're good with that concept here. All right, so we created a pretty simple class here. Again, some class level attributes and instance level attributes. We talked about the leg example, just to go over that one more time. Let's create a new dog instance. Let's call him Hero. It's going to be a dog named Hero. And Hero, for whatever reason, had some accident when it was a puppy and lost a leg. So let's say this is going to be a poodle, and let's say this poodle is going to be, let's say it's a blue dog. I know that's probably not expected, but hey, let's just have a blue dog in here. All right, so we have Hero, which is a blue dog, and otherwise is pretty much the same as any other dog. But Hero has lost an accident in the leg. So what if we did something like hero dot legs equals 3? Now I know I said usually you don't want to modify data members outside of a class. It is possible. In this case, I'm just going to do it because it's quicker, and I don't really have a typical use case where I need to update the number of legs for most dogs. So I don't really want to create a method for it. Again, I could, but in this case, I think it's a very special case. So in this case, I'm just going to update legs. So again, the same thing we're doing with Baxter is what we're doing with Hero. We're creating a new value that's attached to the instance of Hero. So Hero has a new variable called legs that we're going to set to 3. So now anytime we do a print statement, this leg is going to be, this legs is going to be used in preference of this legs for Hero. However, for Baxter and Bailey, we're just going to use the class level attribute. So let me actually uncomment my third function here. This str method is another dunder method. Now let's actually kind of take a pause here and go back to our slides to kind of talk about what we just talked about. So class level attributes and instance attributes. Class attributes are values universal to all instances. So species names, chromosome count, right? Like all dogs have some number of chromosomes. Humans have what, 23 chromosomes. So a human class would have chromosomes equal to 23, and that's shared between all humans. So that'll be a class level attribute. However, instance attributes are unique to each instance. So, name, age, etc. Each dog or each human generally will have a different name or age. Again, you can have the same name, but it's not expected. Therefore, that data is unique to each instance. All right, we talked about Dunner methods. Let's meet the Dunner methods. Obviously, got to put an office pun there. But Dunner methods, these are pre-built methods that you have access to when you create a class. This is what Python has baked under the hood. So you can take advantage of these functions automatically. You do not need to kind of do anything special to have access to these functions. So we talked about the init method. Again, the init method is something that automatically gets called. You do not need to create it, call it yourself. The same goes for pretty much any of these other Dunner methods. You should not, for the most part, call these methods yourself, but these methods will be called by Python depending on what you're doing with your code. So the second one I want to talk about is the str method. Let's actually take a step back. So I'm going to uncomment my str method. I think I got ahead of myself. Let's just print out Baxter here. So I'm going to get rid of Bailey and Hero for now. If I do a print statement for Baxter, let's see what actually happens. So I get bark from speak, because that's what Baxter says. But notice I get this kind of weird output here. I get main dog object, and I get some value. This is actually the memory address where this data exists on my computer, right? So it's telling me, for whatever reason, where this dog object is stored in memory. Well, that's cool, but I don't really care about the memory address at this point. That's not really informative to me as a developer. And like if I were presenting this information to a user, they're not going to care where the data of the dog is being stored on your computer, right? They want to see actual useful information. So that's where the str method comes into play. Again, this is another handy dandy pre-built-in function that you could leverage. So if you create an str method, you can override the default value that gets printed out when you print out your object. So in this case, again, def to create a function, __ str. Again, it must be named this. You do not have control over this. You can't say, I want this to be named string. It's not going to work the way you think it will. It's got to be __ str, take in the self keyword as with any other instance method. And now I'm creating this return. So instead of, whatever memory address and other details got printed out, when I do a print statement, Python is automatically going to look for an str method and call that method if it exists. So it looks like I am a dog named Self. My breed is breed. I have legs, and I'm state sent. All right. So if I clear that, notice we get something much more useful, right? So the only thing I had to do was create this str method, similar to how I created this, print method up here. Same thing going on here, but Python is going to call this for me anytime it needs to represent your class as a string. Or sorry, output it as a string. There's another method called repra, which does the same similar thing. I'm not quite sure the difference use cases, but for the most part, we'll be using str to kind of print out nice things to the console. Any questions about str?
I have a question about init, the init thunder method.
Absolutely.
So if you were to not create or declare a init method, would there be one provided, or would you have to every time?
Nope. So let's say hypothetically, I just left that out. Now I can still create a dog instance, but I can't pass in parameters. So if I, for a reason, decided not to have an init method, I can still do everything I'm doing right now. Delete these values. I'd create a dog that has no attributes initially, but then I could create attributes kind of on the fly. So I could do Baxter.name equals Baxter. And then again, similar to what we were doing initially when we didn't even have classes. So Baxter.breed equals lab and color.
And also to follow up on that, what if you try to access one of those variables while actually declaring a value for it first?
Great question. We will see that shortly. So again, to answer Jason's first question, you don't have to have an init method. In this case, I chose not to, and I'm doing the same exact thing that was being accomplished by the previous init method. So I'm creating a name variable, assigning it, creating a breed, color, and assigning to that. So this can be done, but again, if I always need something to exist, the init method is going to guarantee to exist. What I mean by that, and I think this is Taylor's or goes to Jason's second question. What if I wanted to do something like this? Print Bailey dot name, and then print Baxter dot name. All right, we can get rid of some of this extraneous stuff. So we have two dogs. Bailey is a dog and Baxter is a dog. We want to print out the name of each dog. So I'm going to run this. Notice we get Baxter, which is Baxter's name. Then we get an error because dot name is not an attribute that exists for Bailey because it was never created. Now, this is maybe what we wanted to do, but in most cases, we want each dog to have a name. Like we want to guarantee that. So in that case, the init method is going to guarantee that a name, breed, and color get created for you. It kind of just does the work for you so that you don't have to repeatedly, create these and assign them all the time. Right? So I could do this for Bailey and it would work. But now I'm kind of getting back to that redundant duplicate code that I was trying to avoid before. So this would work. I guess it's the same name, sorry. Bailey. And I think Bailey was just the black lab. All right, so again, init method kind of just guarantees that these members will be created and assigned all in one spot. Questions? Any other questions about the init method? Let's undo all that.
To piggyback on that, if you were to create an instance of another dog, do you have to make sure that you fill out the number of parameters that are there in the init method? So it has 3 parameters, so you need to have three strings or at least 3 blank strings or whatever to get the initialization to go through, or is it throw an error, or is it autofill none or nulls?
Yep, great question. So this is Python. So if you specify 3 parameters for your function, then you must provide 3 parameters from your caller. Unlike JavaScript, where in JavaScript you could have a function that takes in 5 parameters and you can only specify 2. JavaScript is fine with that, namely because it has an undefined type. Python does not have an undefined type. Again, please understand the difference between null and undefined. So Python does have a none type, but that is not the same as undefined. So yep, in Python, you need to specify these parameters. And in fact, that's kind of a feature of using classes, as in, I'm going to guarantee that every object that gets created has these 3 items. There's no way around it, right? Because the way I've designed my interface, I'm saying you must specify a dog name, breed, and color. But if I wanted things to be optional, let's say by default, I'm going to say all dogs are going to be brown. I can say that, so now the caller just has to specify name and breed. If they choose to specify color, they can. Otherwise, I could default. So that's why default values come into play. So when we had that legs example, that was probably more applicable. But yeah, so again, init methods guarantees that the variable will be created. You will need to assign to them, so you can't just say, you can't just create the variable here. I need to actually assign to it. Okay, so that is kind of our introduction there. I think we probably should take a break before we press on into lunchtime. So yeah, let's take a 7-minute break here. So please be back at 11:37. We'll kind of wrap up our OOP introduction here. And if you have any questions that pop up over break, great, we'll answer them after break. So we were talking about some Dunner methods that, again, kind of automatically are available to us when we create a class. So we talked about init. Again, init will be the function that automatically gets called. It's the first thing that gets called by Python when your class is created. Str, we saw that in play with our dog example here. So str just gives a better string representation for your class when you're printing out to console. So if you don't have that, you'll get some weird output, but usually better to have something more human readable via the str method. Again, there's a whole list of other Dunner methods. Obviously, we're not going to go over all of them. There's a repr, which again kind of represents your class as a string also. So again, there's similarities here. I've never used repr or have had to create a repr, but it is useful in certain cases. Equality, addition, you could also represent your class as a dictionary. So again, there's different kind of cool things you could do. So one thing I want to present is maybe the add method. again, you're not usually going to implement these. The two you're going to most likely implement, definitely init, and most of your classes should have a str method. These other ones, very, very lower use case, but definitely can give you some additional functionality. So let's talk about, you know, as I mentioned, you've been using classes all along, but you didn't even really know it, like ints. When you create a variable like x equals 1, y equals 2, you can do such things as z equals x plus y, right? Pretty simple example here. Obviously, z is going to equal 3, but you have this operator that lets you take, two integer objects and add them together. You can also do this with strings, right? If I do s1 equals hello and s2 equals world, I can create a s3 that's equal to hello, maybe add a space in there, and then oops, s2, that's one. Right? You could also add strings together. Now this is obviously doing something a little different than what integers are doing, right? We're not simply doing 1 and then tacking on a 2. We're actually adding those numbers together. So integers behave differently than strings do, even though we're using the same operator, in this case, the plus sign, right? And this is all coming from the class functionality. So the integer class has done something behind the scenes so that it knows to actually mathematically add these values together. Versus the string add method is probably creating a new string, appending all the values to it, and then returning that as your output, right? Because you can't actually modify strings, right? They're immutable. But when you add strings together, it's probably creating a new string object behind the scene, and returning that to you from the plus operation. So we can do that for our classes also if we need to. Again, this is rare use case, but I'm just doing this to highlight kind of these dunner methods. So let's say Baxter and Bailey become friends, and then they decide to maybe add together, if that makes sense. So what if we created a method to accomplish using the plus sign? So if I add a new dunner method, let's add a def add. This method gets called when you use the plus operator for your class. So here. All right, so the add method will take in another parameter, and then we'll return, let's say, create a new dog instance. Maybe not the best example, but it'll be an example. So we'll create a dog that initially has no breed color, or I guess they could have color. I'm not sure what the name would be, but we'll come up with a name and color. So let's say dog breed equals, and just play along with me if you can, will be self.breed plus other dog breed. So I guess you get a lab if they're both labs, but whatever. And then we have a dog color. And I'm not sure how color addition works in the real world, but let's just say it's going to be a combination of self.color plus other dog.color. All right, so we'll do dog breed and dog color. And then we'll return all right, there we go. So we're implementing an add dunner method, and then this does need to take another parameter of other dog. We're going to create a new dog instance and return it from this method. So effectively, now that we have this, we can do something like, what if we did new puppy equals Baxter plus Bailey. I don't know if Bailey is a girl dog or boy dog. I assume it was a girl, but maybe it's a boy. Who knows? Let's just say it's a girl dog. So they add together and they create a new puppy. So now we can actually use this plus operator and actually have some functionality with it. So if I did a print new puppy. Might look kind of weird output. There's no name, but should be able to do that. So notice we get, I'm a dog named nothing. My breed is lab. I have 4 legs and I say wolf. So that's a new puppy we created. Again, the reason we were able to do this is because we implemented this add dunder method. If I did not have that in there, let me comment out some of these prints just to clean up our output. All right, so again, now we're trying to add 2 things, but Python is not going to be happy with that. So Python's like, I have no idea how to actually add one dog instance to another, because that's just not, again, Python isn't that smart to just know what we want it to do. That's why in this case, if we want to use the plus operator, we need to implement an add dunder method. So again, there's different methods for basic operators like equality. If you want to compare 2 dogs, you need to tell Python how to compare 2 dogs. Maybe 2 dogs are equivalent if they have the same name. Maybe 2 dogs are equivalent if they have the same name, breed, owner, and other factors. You get to control that, but you need to tell Python actually how to complete the equality comparison. By default, Python does not know how to kind of compare 2 dogs. All right, again, there's many more methods that you guys can discover. Just know that there's a lot of functionality baked into using classes. Another reason to use classes in Python. Any questions about our dunder methods? If I did a quick Google, I bet I could find a list of them. Dunder methods in Python. Let's have it. Yeah, so nope, that's not quite what I want.
Ankur, if you can you show me your like the other dog function that you created? I just want to see if I mistyped anything or if I missed
The
something.
other dog function. Could you, this add function?
Yeah, correct. The add function.
Yeah, so the add, again, this is reading documentation. So I know I'm just telling you this is the way it is, but documentation will be your guide. So the add function has to take in a second parameter because you're adding one thing to another. So the self is what's going to be the thing you're adding to. And the other dog in this case is what's on the right side of the plus sign. But yeah, so again, dunder methods just give you additional functionality and capability with classes. You guys get more familiar with them, the more you get involved with classes. Just again, no init, no string, don't worry about the rest. This is the main takeaway there. Okay, speaking of takeaways, let's actually wrap up our lecture, make sure the key points are known. One thing, know what object-oriented programming is conceptually. Again, that's the idea of representing things as objects within your code. Know what classes are used for. Classes are your blueprints for your objects you're going to be using. Again, it's the whole idea of reusability. So you create a class so that you can create multiple instances without having to repeat that code. All right, so in our case, we created a dog class, and then we created multiple instances of dogs using the same class. So again, classes give you that reusability and kind of baked in functionality, all packaged together. Previously, when we were, starting off our coding, this worked for us, right? We got the same outputs. We were able to kind of represent a dog, but these items weren't packaged together. It was kind of just like everything was standalone. Even this method didn't really have anything to do with our dog, but we just created a method. Classes, on the other hand, package everything together, right? We have this black box where we don't necessarily know how everything's implemented, but we have ways to access behaviorals such as speak. We can update our sound. We have additional methods that give us functionality. So again, the whole idea of classes is representing objects, and objects have properties and behaviors that they can do. Know how to create a class in Python. Again, we went over that. The basics are use the class keyword, give your class a name, and the way we name classes in Python is camel case, starting with capital letters. So if this were dog, since we're a super dog, I'll name it as such. Super, uppercase D, dog. What else? Yes. class attributes and instance attributes, also know the difference between a class and instance. Again, this is very important for you to understand at this point, because once you get into coding, it kind of get confusing, like, why am I creating an instance? What is an instance? What's a class level attribute? What's an instance level attribute? So an instance is a manifestation or a creation from a blueprint. So a class is kind of your, your concept, your idea. Okay, I know what a shape is. I know what a dog is. I know what a house is conceptually. When you actually build a house, or when you get a puppy, or when you actually draw a shape, those are all actual instances of an idea. All right, and then class attributes, instance attributes. We're going to be hammering this over and over. Very important. Some students do kind of struggle with this early on, but just understand that class attributes are something that every instance kind of has in common, right? So if I'm talking about a human class, every human, for the most part, and there might be, outliers, but for the most part, every human has 23 chromosomes. Every human has, an eye color, hair color. Every human has, 23 chromosomes versus instance attributes. I have a hair color. My hair color happens to be black, but not every human has black hair. Therefore, it would not make sense to create a human class that has hair color as a class level attribute, because that is not a shared property between all humans. So things like eye color, height, weight, so forth, those are instance attributes, because each human has different values for each of those items. But we're all humans, so we're all, Homo sapiens would be our species. That's a class level attribute. We all have 23 chromosomes and so forth. Anything that's shared between all humans would be a class level attribute. Any questions on these key takeaways? Please make sure you are good with these. If you are not, definitely ask questions.
Hey, Anchor, quick question. So for the class and the instance, right? In the example you showed, dog would be the class and Baxter would be the instance of the class?
Yep, exactly.
Okay.
Yeah, so again, class is your idea, as in we all generally have an idea what a dog should be, but then when we actually see a dog, that dog has particular properties that we could actually interact with. So like a dog, has a particular color. So Baxter, for example, was black and white. Bailey was black. Those are instances that have particular instance attributes. Versus when we think about an idea of a dog, we generally think, all right, all dogs are the same species, no matter what. All dogs generally say wolf. All dogs have 4 legs. Like, again, when I'm trying to picture just a random dog, I'm gonna kind of imagine all these things for all dogs. But my imaginary dog might not necessarily have, these items in mind, because they're different between all dogs. Right, so maybe saying that a different way. If I asked you guys to imagine a dog, most of you guys will come up with the same thing here. But I might imagine a dog that's orange. Tanya might imagine a dog that's like striped, black and white or something. Like all of these will be different for our imaginations, but these will be generally the same. So that's why they're class level attributes. Also understand how class level attributes and instance level attributes interact. And we kind of showed that with our example of speak. Right, so what Python does is it's going to look for a variable on the instance first. So in this case, we have a sound variable, but for Baxter, we actually create a new sound variable here. So self.sound is a new variable that we're creating. It is not referring to the sound class, the class level attribute up here. This is an independent value. It's a new piece of memory we're creating. Versus, we had 3 dogs on here. We had Hero and Bailey. Both Hero and Bailey are using the same exact sound value. They're not creating copies of it. It's the same value that is being shared by multiple instances. All right, if we wanted to update a class level attribute, we can. We could do dog.sound equals bow wow. Now this would impact every single dog. So both Bailey and Hero will now say bow wow, but Baxter will still say bark, even if we put this up here, because Baxter has made a unique value for that instance only.
Just a quick question. If you changed it after you made all the dogs or whatever, would it then go back and change that point, or would it function more like for the next dog?
Yeah, so yeah, good question. If we change it down here, well, it's not going to automatically like go back in time. Like, right, our code's sequential, so it's going top down. So if I ran it this way, our dog should still say bark. Let's have hero say something. Hero.speak. And let's print out hero. Print out Bailey. And print out Baxter. Okay, so if I ran that, yeah, so I'm setting this down here. So bow wow is not going to be used. Except I do have the addition down here. So I forgot about my code down here, but our new puppy says bow wow because we changed it at this point. Sorry, I forgot about that. But notice that hero has printed out 3 legs because we have specified that an instance level attribute created it called legs and assigned that to 3 for hero. So now when we do the str, when the str method gets called, it looks for self.legs first on the instance. For Baxter and Bailey, there's no legs on the instance attribute, so it's gonna kind of migrate up to the class level, which has legs equals 4. But for hero, we have a special case where we created an instance level attribute, so that gets preferred. So that's why we have 3 legs for hero. Okay, so again, understand when to use instance attributes, how they operate versus class level attributes.
We'll keep repeating this every day.
Yeah. What questions do you guys have? Again, you guys we'll have challenges today that will give you more comfortable classes. So let's actually take a look at those challenges. Today is 11th. Let's go down. All right, so again, review the lesson, make sure you kind of understand what we went through. Again, instance methods, instance attributes. The one thing we did not talk about was class level methods, but the idea is the same. So if you have a method that applies to all dogs, you wouldn't have an instance level attribute. But again, we're not going to get to that today. Just understand you can have class level attributes that apply to all dogs. In this case, we have instance level attributes because each dog is going to speak for itself. All right, so we have 3 challenges for you tonight. One is called app users. This is kind of an introductory challenge just to get you familiar with creating classes. So we're going to ask you to create something, a user class that's going to have certain properties. In this case, name, email address, driver's license number. Maybe you could add a few more. Again, just don't always kind of just take our requirements and implement them. Always try to add on if you think of something that makes sense. So basically, this challenge asks you to create a user class and then create a few instances of the user. So kind of just getting practice with basically what we went over today in lecture. We did a dog class. You guys will be creating a user class. This is going to be a 3-part challenge. So today you're going to do part 1, part 2 tomorrow, part 3, just kind of building upon this challenge. So as I mentioned, our challenges are kind of going to get longer instead of having more numerous challenges. Then we also, so throughout this week, we're going to give you object-oriented programming challenges, but also you're going to be having algorithmic challenges every day also. Because when we don't want you to kind of lose that algorithmic side of problem solving of software development. And also your assessment is going to be purely an algorithmic based challenge. You're not going to have to write classes aside from the unit test stuff for assessment 1 on Friday. So every day you'll have classes and algo challenges to work with. We have guessing game. I don't know if you guys play this as kids, but maybe a good card game. Basically, I think of a number, and then you guys would have to guess what that number is. But let's say it's between 1 and 100. I pick a number. Let's say you guess 47. I'll say, nope, the number is higher. So you know kind of what range you need to search through then. So you might guess like 83. I'll be like lower. You guess 52, and I'm like, yep, that was a number. Great guess. So you're going to be implementing that as this challenge. So build a simple guessing game. We're going to ask you to use a class. So again, you probably could solve this without classes, but we want you to use classes. So this is what basically how you should be accessing your class. So we have the runner file here, which is you're gonna create an instance of guessing game and then call these methods on it. You're gonna check .solved should return true or false, depending on if the puzzle has been solved or not. If someone guesses something, they will input a guess, and then you should return if the value is too low or too high. Guessing game, yep. All right, so if I guess 5, that's too low. If I guess 20, that's too high. The puzzle is still not solved, but then someone guesses 10, which should output correct, and then at any point, the game should be solved. And then you could create another instance of a game with a different number. So notice here, we're putting in the actual value. If more realistically, you want to pick a random number. So there's a random library you can use with Python. So you import random, follow the examples or read documentation. Again, we're definitely going to push you to read documentation. But in this case, if you want to create a random number between 1 and 100, you call randint on the random module, and that could kind of seed a random guess that you can try to accomplish. All right, so we have some starter code for you, or driver code, that should tell you what your class should look like. Again, your class that you create should have a solve method, should have a guess method, and work with the runner file here. All right, and then the last challenge is our algo-based challenge. So Caesar Cipher. I think you guys had a similar challenge maybe in the pre-work or the application challenge, but basically Caesar Cipher will take in an input, a shift value, and then you should be able to return a string with characters shifted. So in this case, 5, we're shifting each character 5 characters in the alphabet. So A becomes B, C, E, F, right? A, B, C, D, E, F, yeah, 5. So that's why we have an F there. All right, so again, we have some pointers wrap around. So Z becomes A if you shift it by 1. Keep the same case, ignore punctuation. Pretty straightforward what we're asking for, but again, just another algorithmic challenge for you guys to tackle. All right, so those are your challenges. Again, only 3 tonight, not 7, so maybe that's some benefit to you guys. But what questions do you guys have about challenges, or again, anything OOP related from our introduction today?
Ankur, I have a question.
Go for it.
We don't have to create test files for the game and the user app, do we?
Game? No, you do not.
Okay, thank you.
You can if you want.
Yeah, I don't think we even say in our Caesar Cipher, you don't have to, but as I said, assessment 1 has test room development on it. So more practice, the better you'll be at it. So again, we're not going to always say do X, Y, and Z, but that doesn't mean you don't have to or you shouldn't. But good question. Here to ask it. Okay, well, those are your challenges. I think we're hitting lunchtime. Yep, we're 1 minute past lunchtime. All right, so take a lunch. Please be back by 12, let's say 12:58, because we're gonna have a guest speaker at 1 o'clock. I know we've said this before, like during lecture, please try to have your camera on. That's especially true for our guest lecturers. Obviously, we want to make sure they feel valued and that they have an active audience. So if you, whatever reason, don't have your camera on during lecture, okay, but please try to turn them on definitely for our guest speakers. Okie dokes. All right, enjoy your lunch. Please be back at 12:58 in the Zoom room, and we'll look forward to a great presentation by Nicole Carpenter. All right, see you guys in a bit.